with two dots on it like that, that means we're defining it to be that. So we are defining 0 factorial to be 1.
Isn't that kind of cheating then? So then it's not like making all the other numbers 0?
Is it like what?
Because if you went to 0 like on all these.
Well, we don't go to 0 though. You stop at 1. I know. Look, define it this way. Don't worry about why. Don't try and fit it into that pattern. Just say, when we see 0 factorial, it's 1.
You're going to tell us why?
Nope. Not ever going to tell you why. Sorry. You can study the gamma function, which is actually a more general version of the factorial function. So if you ever take a math class where you study the gamma function is actually this function defined for every number in between. So you can do it for fractions too. And it's defined at 0, and it's an improper integral. The gamma function is defined as an improper integral. It's weird. But beyond the scope of this class, for here, we'll just take that on faith. All right? Factorial comes up in statistics a lot with probabilities and things. So, but here, for us, it's going to come up with these power series. Factorial is actually going to be embedded into a formula that we're going to get called Taylor's formula, or Taylor series. It's called a Taylor series, and in that formula, the formula for a Taylor series, I'm going to write it up here. It won't make any sense right now. Missing something. We haven't even talked about this symbol yet, but it's an infinite sum. And guess what's here? I didn't do a good job. N factorial. So we use it all the time with series. So we need to be comfortable with it. And there's some properties of factorials that I want us to discuss here. What is n plus 2 factorial over n plus, or just let's say n factorial? So this is an example that's going to help us see some of the things you can do with factorials. Well, n plus 2 factorial on top is n plus 2 times n plus 1 times n minus 1 times n minus 2. And I keep doing this all the way till I get down to where?
To 1.
To 1. Right? So what you do when you do a factorial is you take the number that's here, right? You write it down. The next one is 1 less than that, then 1 less than that, then 1 less than that, all the way until you get down to 1. Yes? Then you divide that here by n factorial. But n factorial, you write down n, then n minus 1, then n minus 2, all the way till you get down to 1. And do you see something that happens here? You can cancel a lot of stuff here, can't you? This n, this n, this n, this n, minus everything, right? To the right there? That's all gone. They all reduce out to be 1s. And so all you're left with is what? N plus 2 times n plus 1. You see how that algebra works? Any questions? Now, we don't want to do it that way, okay? That's just to show you what we should get as an answer. Here's what I'm going to do instead. I'm going to write this down, n plus 2 times n plus 1. And then I'm going to realize that the rest of it is n times n minus 1 times n minus 2 times n. So the rest of it from here on is n factorial. Do you agree? Yes? Divided by what? N factorial. And they cancel here. See the difference between doing it that way? It's just cleaner, quicker. you get the same result, don't you? So this factorial symbol is attached to this n only. So this means, this whole thing means this, right? That's n factorial right there? Okay, so that's what this is in this piece. So let's see if you can simplify another one. What about n minus 2 factorial over n plus 1 factorial?
Maybe n minus 2, n minus 1, n.
I want you to think about it.
N plus 1 and n minus 1 and minus 2 factorial.
Wait, say again?
Keep the n minus 2 factorial on top, bottom is right. N plus 1 and n minus 1.
Okay, so you want me to not touch this one?
Sure.
And start breaking this one down?
Sure.
Why?
We're going to do 1 over n
Because
plus
don't you
1.
keep subtracting
See,
on the top one? So you're going to have to reach n plus
Which one of these is bigger?
top bottom.
The bottom one's bigger. N plus 1 is bigger than n minus 2, right? See, up here what we did is the bigger one, we started peeling the big one down until it got to become the smaller one, and then canceled them. So I'm going to start peeling the n plus 1 down until it becomes n minus 2, and that's where I'll stop. So that's correct. I'm going to leave the n minus 2 factorial alone on top. And on the bottom, I'm going to write, what, n plus 1.
N.
Then peel 1 off, n, subtract 1 again, n minus 1, subtract 1 again, n minus 2. And then I could keep going, right? But instead of keeping going, I just attach the factorial. Remember, that factorial implies that it's only attached to there. So that would mean, this right here would mean n minus 2 times n minus 1 times the rest of the way. But that's all I needed because these cancel, right? And so you're left with 1 over n times n plus 1, or sorry, n plus 1 times n minus 1. Got it? Questions? How about this? What's 2 times n plus 1 factorial over 2n factorial? What 2?
Every time you do a factor.
2.
N 2, yeah.
Right, so then
The 2's going to stay.
but it doesn't matter, like when we do the factorial, it doesn't matter, like if because we can just continue the factorial, right?
On top, can we multiply the 2?
Oh, I'm getting too many, I'm getting overload here with different things to do. The factorial is acting on everything in that parentheses, right? Okay. Factorial is acting on this. Now, that's important because if I write this, just everyone on the bottom, if I write this, what's the factorial acting on? The n only. If I put in parentheses, it's acting on both of them. So this right here would mean 2 times n minus 1 times n minus 2. Keep going, right? Versus this, which would mean, what do I start with? 2n, and then 2n minus 1, and then 2n minus 2. And you see the difference between those? Yes? It's very important that you see the difference between those two.
Then it'd just be 2n plus 1, right? Because when you factor out the next one, it'd be 2n, and then they would just cancel out, right?
I'm not quite sure what you're saying.
Expand the top one.
Right.
Expand, how do you mean expand?
Continuing, so it'd be
Distribute the 2? Okay, that's what I wanted. You want me to distribute this 2 through?
Yeah.
Yes? And that becomes 2n plus 2 factorial. I agree with that. Yes?
Yeah.
And then on the bottom 2n factorial. And those two, eventually, one of those should turn into the other. Which one am I going to start peeling apart? The top one, right? So if I start peeling the top one apart, I get 2n plus 2 to start, right? Then 2n plus 1. See, what I'm doing is I'm subtracting 1 from this, right? Subtract 1. You can't subtract 1 from 2n, right? So you subtract 1 from 2, you get 1. The next one will be 2n, and then that's the bottom, so I want to just continue that the rest of the way with a factorial. All over 2n factorial. These cancel. You get 2n plus 2 times 2n plus 1. Questions? Are you sure?
When you give us a problem like that, where will you give us like current n, like know what to plug in?
You're never going to plug an n in.
You're not.
No.
Oh.
You're going to let n go to infinity, but you're not going to plug it in. Where the heck? What I'm doing is I'm going later in the chapter and I'm pulling some ugly problems. Okay, here we go. I want us to try and simplify this, okay? That's what we're doing here, simplifying this. I want us to simplify two to the 2 times n plus 1 over n plus 1 factorial times n plus 2 factorial over 2 to the 2n over n factorial times n plus 1 factorial. Look, we've got to be able to simplify that later, so we may as well mess with it now. I want us to clean that up, simplify it. Okay, so you see big fractions multiply reciprocal? Yes, can we do that?
Yes.
All right, so if I do that, I can go, let's see, this one up here is get multiplied by that reciprocal, so n factorial, n plus 1 factorial over 2 to the 2n. Y'all agree? Time we got. That wipes out those, right? And then n plus 1 factorials will cancel.
When you distribute the 2 to the n plus 1, the 2 n's would cancel because when you divide exponents, it cancels.
Okay, so yeah, let me do that. So you're going to say multiply that through up there.
Right.
Okay, so let me do this. 2 to the 2n plus 2
Right.
over n plus 2 factorial times n factorial over 2 to the 2n.
And then the 2 n's would subtract each other, right?
Since these have the same base, you can do subtraction of the exponents, or you can split this into 2. So either way, I think what I'll do is I'll split this into 2. So I'm going to write it down just so you see it, all right? Later on, I won't write this down in this much detail. Okay, do y'all see what I did?
Yes.
So I broke this apart, and then I did the factorial breakdown on the bottom left corner to get the n factorials to cancel. So this is going to cancel here. This is now going to cancel with this. And so you're left with, at the end of the day, 4 over n plus 2 times n plus 1. Later on, we'll be doing this in a bigger kind of context of a bigger problem, and we'll be letting n go to infinity, and we'll see that this would go to 0, wouldn't it?
Yep.
And when that happens later, do you remember I was showing you the functions, like sometimes it only approximates on an interval and then sometimes it's everywhere, right? Like it works everywhere. This would be telling us that it works everywhere if it goes to 0 here. But that's later. We'll have to do a limit. Yep. Later. 20 minutes. So let's say someone's given us a sequence, okay? We've got the sequence. We will write limit as n goes to infinity of a sub n equals L. Or we sometimes write a sub n with an arrow to L, like this. When as n gets large, the sequence approaches L. Now we did limits in Cal 1. And the idea in Cal 1 of a limit was that as x got close to a value, the function got close to a value without actually ever necessarily needing to get there. So if we write that the limit as n goes to infinity of our sequence equals L, or if I write a sub n with an arrow going to L, what I mean by this is that when n gets bigger, my sequence is actually getting closer to some number. I don't have to ever achieve the number. I don't ever have to get there, right? I just have to get closer and closer, right? So continuing this. In this case, that a sub n goes to L, okay? In the case that this actually happens, we say a sub n is convergent. Or it converges. Otherwise, we say A sub n is divergent or diverges. So let's look at some examples. Hmm?
Why'd they name those books and those movies that, like, Convergent or Divergent? You know the movies?
Yeah, I was thinking the same thing, man.
Really?
Yeah, I was like,
You already said that. I think of the movies. I'm like, why did they name them that?
Why did they name it Jurassic Park and all the dinosaurs are from the Cretaceous period?
No, man.
Cretaceous. Yeah, may not sell. May not sell. Hey, I think we got lots of whys. We got lots of whys. All right. So here's an example. Does A sub n converge or diverge? If convergent, find its limit. Here we go. You ready for some examples? All right. I have to give you a sequence first, right? So how about this one? We'll start out with a nice one. First example, I'll call example A. Let's see. A sub n equals 1 over n. Before you tell me an answer, what does this sequence look like? 1, 1/2, 1/3, 1/4, forever, right? Are these numbers getting closer and closer to something? 0, right? 0. So it converges. But in terms of a limit, I'm doing the limit as n goes to infinity, right, of 1 over n. And I hope that's obvious that as n gets bigger, that ratio gets smaller. So this does go to 0, right? So the answer for part A would be that it is a convergent sequence, right? And it converges to 0. Fair enough? Okay, how about this one? B. A sub n equals sine n. Why?
First off, doesn't even like go past 1?
If I were to write it out, it would be sine 1, sine 2, sine 3, and you would actually need to get your calculator out to figure out where those were.
Yeah.
What do you know about the sine function, though?
It only goes up to 1.
Highest it's 1, lowest it's -1, and it oscillates, right? But this is a sequence, so it wouldn't look like a sine function. It wouldn't be nice. I couldn't draw it without picking up my pencil, right? It would be like dots, right?
Yeah.
And I can't really tell you where those dots are going to hit. I just know that they would, well, what I should have done is, I should have just drawn the sine curve first and said the sequence has to be dots on that, right? So the sequence is like maybe here, and then maybe the next one's there, and maybe the next one's there, and the next one maybe is there and there. So it's just these dots, right? Those dots are not approaching a number. Now they are bounded, right? They're between two numbers, but they're not approaching anything. And because of that, it diverges. How about this? What are you thinking here?
It's not integrated.
What? Integration by parts? Is that what you said? Trig sub? Wait, what? What? What's happening here? As n goes to infinity, what's happening?
It's going to 0?
What is going to 0?
The fraction?
Is it? How do you know?
Oh, no, because it's never on the top.
The top's also going to get bigger, isn't it?
So it's going to just diverge then?
I don't know. That's what we're having. That's what we got to figure out.
Oh, you can't do it.
We can plug in numbers, see what's going on there.
Yeah,
But if it's
that's
infinity, you can't- you
that's
have to
dangerous.
right?
That's dangerous. What?
You have to rearrange it to get like infinity times infinity or something? Because it's
What do we have? What kind of form of a limit do we have here? What's happening on the top? Where is it headed?
going to infinity.
It's going to infinity, and the bottom,
Infinity.
right? This is like infinity plus infinity. Root of infinity is still like becoming infinite. And when you have that, you can't tell what the answer is. So what? L'Hopital? Here's the problem with L'Hopital, though. L'Hopital required that, well, L'Hopital said you do the derivative, right? Top, bottom? We can take derivatives of functions because the whole idea of a derivative is that if you have a function, the derivative is the slope of the tangent line, isn't it? That's what the derivative is. But the way we got it, if you go back to the very beginning of Cal 1, what you did is you actually did this thing called a secant line, and what you did is move this point closer to this one, and then you actually got the tangent line. Do you remember that? It was actually a limit. You get the tangent line from a limit. That means there has to be points next to the point you're looking at in order for you to come in and take a limit. On a sequence, you have a bunch of points. How can you come in and take a limit from both sides if you just have points? Do y'all get what I'm saying? Like, if I tell you to find the tangent line, so let me draw your sequence. I'm just making it up. Okay, there's your sequence. I'm not telling you anything about it. And I tell you, hey, go to this one right here. What's the slope of the tangent line? Do you see why that's not going to make sense now?
Yeah.
You don't have a curve. You just have a bunch of dots sitting out in space. So L'Hopital is not allowed until next class. And then I'll show you there's a theorem that will allow us to use it.
Can you just bring it up then? Like, then no negatives, like, never mind, -1.
No. Anyone know how to do this limit without L'Hopital? It gets uglier with L'Hopital, doesn't it? I think it does. It gets worse with L'Hopital. I wouldn't want to do this one with L'Hopital. You only have one root, so the conjugates, you want two things. What we got? See if this looks familiar to you.
I was thinking it's not integral.
So why am I choosing to do that? Some of you, if you've taken, depends on your instructor, they may have shown you to do this instead. I think maybe some of you may have been told to do this on top and bottom instead. The whole goal here, instead of this, do this. They're the same thing. okay? But the whole goal here, when you see infinity over infinity, when you've got polynomials and roots like this, is to try and turn the highest power of n, in this case, turn that into a 1. Okay? Highest power you see down here is n to the 4th, right? I need to turn that into a 1, so I need to divide it by n to the 4th. And the way I do that is by doing this. And you might ask, why did I not use n to the 4th? I mean, why did I use n squared?
You're going to go into square root.
Because when you force something into a square root, it gets squared. When you pull something out, you take the square root, but when you put it in, it gets squared. So if I square 1 over n squared, push it into the root, it becomes 1 over n to the 4th. On the top, I don't have to push it into a root, so it's just going to become limit. N goes to infinity. The top here, that's a 1, isn't it?
Yeah.
And then I have square root of, push this in here, it becomes 1 over n to the 4th. Agreed? Yeah? Okay, you've seen this before. I know for a fact you've seen this. You comfortable with that? So when you came out, the power went down, right? So what if I tell you to put that back in? You got to square it when it goes back in, right? That's what I'm doing here. Okay? So now go here to here. 1.
Plus it.
Here to here. 1 over n cubed. Now look at that. That's a limit we can do. But n go to infinity now.
0.
This one goes to 0, right? And then 1 over root 1, it's just 1. The sequence converges to 1. So I think I'm going to cut you loose on this. Your homework, it converges to 1. Page 434, I want you to look at 5 through 32. So the first 4 are, here's a sequence, come up with the formula. The rest of them are all these limit problems. Now, you're going to have some trouble possibly with these, so I will recommend that you go back and look at L'Hopital's rule again. Do all, just go review. If you have trouble on this, if you get to a problem where you're like, I don't know how to do this without L'Hopital's rule, then just wait. All right, because we're not done with this section, but I want you at least to start looking at some of these limits you're going to run into. And some of them you can knock them out, some of them you can't. All right, have a good weekend.
Where are your limits and L'Hopital's rule videos going to be?
My Cal 1 class?
Cal 1?
Yep.
Anything else?
Nope. Cal 1. Notes?
Just the lectures, so to speak?
No, I usually don't have like written out notes for